Okay, we'll go ahead and get started. Hello and welcome. This is Julie with ProSoft, and I'm really excited to present this webinar to us. Thanks for joining. This is incorporating power protection equipment into Rockwell Automation ControlLogix PACs. One quick thing before I introduce Eric, I want to tell you about the Q&A box that's at the bottom of your screen. If you can just post your questions in there, we will get to those at the very end. And with that, I'm going to go ahead and introduce Eric Syme. He's our product manager here at ProSoft. And go ahead and take it away, Eric.
All right, thank you very much. Thanks everybody for taking the time to join today's webinar. I appreciate it. Hopefully we can have some good information for you. But yeah, we were going to talk about incorporating some of your power protection equipment into Rockwell Automation ControlLogix systems. So when we talk about or look at some of the power protection equipment, a lot of times we're addressing IEDs that are used throughout various applications within a control system. And this data from the IEDs is used to, it's integrated into the control system. It's done for some substation automation. And a lot of times the information is further passed up into either a SCADA or utility enterprise level. And really with the rise of Ethernet connection between these devices, we've been able to achieve a lot of new efficiencies. The IED vendors have been able to come up with some very advanced control schemes that they can accomplish with the or control and protection schemes that they can accomplish with these devices and the support of Ethernet. So when we really look at where these applications occur, I like to always say that if you find yourself in a room like the picture on the top right-hand side, that's really where you can incorporate some of these devices into your control architecture. These power protection relays are used in anything from power generation applications, pulp and paper, oil and gas, metal and mining, heavy materials. And then as far as some of the, you look at like Rockwell Automation, they do have a packaged power product offering that the products that we'll be talking about today are a critical component of that intelligent packaged power product offering. So when we look at really these devices and how we integrate these into ControlLogix systems, it has traditionally been on a Modbus communication network. That was kind of the first implementation, then kind of migrated over to like a Modbus TCP/IP network. But then there's also been some very specific protocols that have been used in integrating these devices into a control architecture. DMP and IEC 60870-5-101, 103, and 104 were protocols that were some of the first ones that were really designed to for these devices and came up with. Modbus was kind of like a de facto standard just because everybody supported it, but DMP and the IEC 60870 protocols came out, and they basically addressed some of the issues with Modbus and were specific to the power protection equipment. But even those protocols came up short on some areas. And so really what the protocol that we see rising quite a bit, and one that is a preferred protocol used in these applications, is the IEC 61850 protocol, which it's a newer standard, but it's really helped to address some of the shortcomings of the other protocols, and has really given us some great features and functionality that as we look at bringing that into ControlLogix systems, we've been able to take advantage of. So what is IEC 61850? It's basically an international standard for substation automation. It defines not only the communication between the devices, but it also describes and has a structured support for interoperabilities between various IEDs. They went so far as to define a common configuration language. And really the benefit that we see with 61850 is the fact that they were able to adopt a data model approach, a standardized service for different device behavior models, standardized object models and naming conventions. And really the key thing that that I really like about it is the self-descriptive tags. And so when I look kind of at the self-descriptive tags, it's something like this where you've got a logical device, which is in this case, it could be your protective relay. You've got a logical node, something like a XCBR, and there's several of these logical nodes that are defined in the protocol. Then there's the data, and then there's the attribute. And the nice thing about this data model approach is it really has become, it's vendor neutral. So any device, such as a circuit breaker protection device, is going to have this XCBR logical node defined in it. And so what that means is it allows you to go ahead and it's self-descriptive tags, but it also gives you a standardized format that even if you're going to different vendors' equipment or you're switching from one vendor to another, that same logical node is there. So you're not having to relearn and readdress all your stuff all over again. And I look at kind of this data model approach and these self-descriptive tags as really, if you think back to RSLogix 5 and 500 for PLC 5s and SLC 500s, and then out came ControlLogix and Studio 5000, or at the time RSLogix 5000. You now, instead of having N7 tags and N10 tags and F8, you were and hoping that somebody put comments in the PLC code. You really now have the ability to have these self-descriptive tags that mean something when you look at it. And what that does by having these self-descriptive tags, it really gives you the benefit of you can get a savings of up to 75% in your configuration time. You get some major reductions in just the efforts and configuration efforts, and really that we're getting a lot closer to this plug and play. It helps to really be able to get these devices online, troubleshoot and commissioned much quicker. And these self-descriptive tags is a starting point for that, as well as the configuration language. And then as you're passing this information up to different layers throughout your automation scheme, up from the controller up to the SCADA layer, you don't lose any of this information. So it becomes very helpful right there. So one of our products that we've had for years that's been able to incorporate and take advantage of some of these 61850 features is our PLX82 EIP 61850 gateway. And so it's a standalone gateway module, and it allows, goes out, communicates with these protective relays out on the network, brings that information back in, and goes ahead and allows you to pass that information over to ControlLogix. This is a product that I believe we released it in 2014, so we've had it out for about 7 years now, thousands of successful installations worldwide, and customers have been able to achieve and see some significant benefits off of this. One such example was a powerhouse that we did that we actually had, we incorporated around 54 of these protective relays into a ControlLogix system. And we had a total of 12 individual gateways out there. We took advantage of some wireless communication using our Radio Links products. And then we also had some of our MBI 56 modules that fit directly in the ControlLogix chassis in addition to the gateway. And how our customer was able to take advantage of this and see the benefit was, if you look at the old way that they were doing it, they had these protective relays and out in their plant, and they had a standalone RTU unit that they had to, basically these relays were communicating 61850. They had to program the standalone RTU unit to go ahead and grab information from 61850 and then put that into a Modbus TCP/IP network. And then they would use one of our in-chassis Modbus TCP/IP cards, our MBI5060-MNetC module, to go ahead and get all this information. And this worked. I mean, it worked very well, very reliably. It had quite a bit of setup and configuration that was associated with it. Not only were you programming in ControlLogix, but you're also programming in the standalone RTU device. You also had an Excel spreadsheet that you had to keep track of to basically say, okay, well, this point on my 61850 network is now this point on my Modbus TCP/IP network. And anytime somebody went and made a change, you had to hope that they actually updated the Excel spreadsheet and put the latest and greatest information in there. So, so while this worked and worked very well and reliably, and it was a lot of setup and configuration. They said that it typically took them about a week to program, configure, and commission something like a setup like this. So when they went ahead and tried out our gateway communication module, they were very surprised on just the tight integration that they were able to achieve with the same network. So by eliminating that standalone RTU device and utilizing one of our gateway modules, they were able to essentially take that data model that was on the IEC 61850 network and bring that all the way up into the Rockwell ControlLogix network. And so with our standalone gateway, we have this configuration software, which basically allows you to map data, and then it builds custom add-on instructions that can be used in RSLogix 5000 or Studio 5000 to basically give you that exact same tag name all the way up through. And then furthermore, you can bring that all the way up into something like FactoryTalk View. And so there's no keeping track of an Excel spreadsheet or anything like that. And really the benefit for this customer was they were able to reduce that 7 or the week-long configuration setup, commissioning time. They were able to reduce that down to a couple hours, in many cases as short as like 3 hours. And so they really were able to get these systems up online much quicker and much more efficiently. So that was that's been our gateway solution that, like I mentioned, we've had this around since 2014 that helps solve and integrate these IEC 61850 solutions. So, but even at that, that was released about 7 years ago. And so we've had, over the last 7 years, we've had some requests for enhanced functionality. And so that's where we've developed a newer solution that will be coming soon. Third quarter of this year is our anticipated release. But it's a IEC 61850 client module that fits directly into the ControlLogix backplane. And this allows some similar functionality to what our gateway module has, but it really builds upon some of those customer applications that we may not have been able to solve as well with the gateway module, and gives us a very integrated in-chassis solution. So again, this solution provides multi-vendor capability. So the 61850 protocol, like I mentioned, can be amongst multiple vendors such as SEL, ABB, GE. even Allen Bradley has some of their 857 relays that support the 621-850 protocol. This module also kind of takes advantage of some additional functionality that we've wanted to do for a long time. So really one of the key things that we've been able to do with this module is we now can support up to 40 IEDs with a single module. As we looked at our gateway module that only had the capability to support 20, we've been able to double that with this new module. Additionally, with our gateway module, we've been able to support MMS and Goose subscriber for years, but this is our first product that allows us to be able to support Goose Publisher. And what that does is this really opens up the ability to, for some of the more advanced and time-critical protection schemes, we can now take advantage of Goose Publisher from the ControlLogix side, publish Goose messages to the IEDs on the network. And what this can effectively do is eliminate some of the need to hardwire I/O back to these relays or to the control system. And this is achievable only through the fact that we can support some very fast I/O connections, and a lot of them. The module itself can support I/O connections all the way down to 4 milliseconds, and it can support up to 225 I/O connections on the ControlLogix side. Now, not all of those are at 4 milliseconds. That's highly unrealistic right there. But we can support up to 50 I/O connections at the 4 millisecond timeline, and then a lot of your MMS data and some of the lower priority data can run at higher RPI times within the ControlLogix processor. But this module is one of the most powerful modules within the ControlLogix backplane, and really provides a ton of communication data. Just to put it in reference, our old gateway module supported 20 I/O connections. So this module supports 10 times the amount of data that we had previously. So we still went ahead and took advantage of our tight integration within Studio 5000, but we kind of built upon that with this new module. We've got a custom add-on profile that can be installed in Studio 5000. It does require Studio 5000 version 32 or greater, but that Studio 5000 can launch our configuration software from directly inside this custom add-on profile. The configuration software then goes ahead and builds, not only does it build an add-on instruction that can be used to map the data over the controller tags, but also for some of your high priority data, it will go and build the actual controller tag in the connection. So if you see at the bottom there, you got the local 1:I, meaning that the module's in slot number 1, and then the first input connection, but it's actually building out that tag directly in ControlLogix. So that information, the nice part about this being all integrated within an add-on profile is it's stored directly in the processor. So if you've got, in the event of a device failure, and say for instance you have to put a new module in its place, it is simple as easy as just going ahead and automatic device recovery. You plug a new module in, it gets the configuration from the processor, and you're back up and running. So again, like I mentioned, the 225 I/O connections is something that we're very happy that we were able to achieve that, and the ability to define some of those as high priority connections is a great enhancement for this solution and some of the applications that we're able to solve. So as we look at just comparing our old module with the old gateway module with this new in-chassis module. Some of the key things that I've touched on, I already talked about the IEDs supported, the IO connections, 225 IO connections. And really, if you look at this, it's we're twice as many IEDs with 10 times as much IO data. And really the reason for that was on our gateway module, as we started looking at some of the applications customers were performing, the limitation was not the number of IEDs on a lot of instances, it was the total number of IO connections. So by doubling the amount of IEDs that we can support and going up to 10 times on the number of IO connections, we feel that we can truly build out networks of 40 IEDs and with some room left over on those 225 IO connections. We've also been able to add the ability of the PRP or parallel redundancy protocol, as a lot of the protective relays on the market have come to support that protocol. It was a limitation that we did not support on our previous solution. And we are allowed to, we do support it on this new module. Like I mentioned on the Goose Publisher really allows us to push data from ControlLogix over directly to the protective relays. And previously on our gateway module, we were only doing that with hardwired IO. We also have the ability to support IEEE 1588 with the power profile. And so that allows us to synchronize those protective relays. And a lot of times and since we also support the SIP sync time synchronization, it's basically you're allowed to, it's now very transparent, passing from a SIP sync time synchronization over to 1588 with power profile support. So the same clock that's being used to synchronize your ControlLogix network is now can be used to synchronize your protective relay equipment. And then lastly, we're in the process right now of doing DNVGL, which used to be referred to as KEMA certification. So back in 2014, when we released the PLX82 module, they really didn't have a certified test procedure for clients. It was more for server-based modules. But since then, the protocol's adopted, and so we are currently going through the certification process there. So yeah, as I mentioned, the PRP provides that high availability Ethernet network. So now with, I mean, a lot of you take advantage of DLR on your Ethernet IP networks to provide that redundancy and that high availability. PRP is what's used on a lot of the power protective relays. So we can now support that, along with the Goose Publisher, which provides that fast ability to push data out to the protective relays on the network, and then the 1588 time synchronization and SIP sync will allow us to, really that allows you to eliminate a separate time source. A lot of times we saw you would have your time synchronization source on the ControlLogix side, and then you'd have to have a separate time synchronization source on the protective relay side. This allows you to essentially pass that clock all the way over to your protective relay network, thus eliminating some additional hardware. So, and then lastly, this is integrated, both the gateway module, the PLX82, and this new MBI 56E62850 module are both integrated within the Plant PAX library. So Rockwell Automation has gone through and as part of their Plant PAX library, they've created power protective equipment for various devices from SEL, ABB, and GE Multilin. And so these are predefined add-on instructions that can go into the controller, along with faceplates that customers can take advantage of for some of these visualization things. You can utilize that on panel views or factory talk view, get that information displayed, and so you're taking advantage of some of the work that they've done to get the visualization aspects up in there. So that is just information on 61850 and a sneak peek at our new in-chassis module that will be coming out in Q3 this year. I do believe we've got some questions right here. So one of the first questions that came through was I going to cover the setup basics on some of the CID files and how they're used. Unfortunately, on a very short webinar like this, I didn't have enough time to go digging deep into how the configuration of 61850 networks is done. But we can definitely look to schedule some more advanced configuration and setup questions later on. Another question that came through is, are you able to send control signal from the PLC to the relay using Goose or MMS? So we are now able to send Goose control messages from the PLC to the relays with the 61850, the upcoming MBI 5060 61850C module. That's what's referred to as the Goose publisher. On the PLX82, the gateway module, we've always been able to send control messages via MMS, and we will support that on the new in-chassis module as well. So we will be able to support both of those on the new module, and then only MMS control on the gateway module. So we can support both of those. There was another question that came up on the gateway module. It looks like you have a EIP and 61850 port on the module. And so, yeah, I'll just go back to this slide right here. And that is absolutely correct. There's a dedicated port on this PLX82 module that there's two ports on this module. It does not support the PRP network. One port can be set up for a dedicated 61850 communication. The other port can be set up for both Ethernet IP and 61850 on the same port, or it can do Ethernet IP only. So this module has some flexibility. When we first released, we used to have a PLX81 version of this module that only had a single port on there. And as that product went end of life, we had to, we basically chose, instead of coming out with a dedicated PLX81, we combined both a single NIC support and dual NIC support in the same gateway module. So there's a question about backplane comms too. I believe that means, yeah, the IO. So on the gateway module, the IO connection is directly through Ethernet IP class 1 IO. So, and then on the backplane side, it's in the ControlLogix module is very similar. So another question came through. Have you tested what is the average estimated time required to send data from the IED to ControlLogix back to the IED by using this gateway? So we did do some performance testing with the gateway module, and really it was dependent on a couple of factors. It's really was the number of IO connections and the number of devices on the network. What we saw is, in general, if you had a fully loaded module and network, your IO updates needed to be somewhere around 250 milliseconds to get data back and forth. as part of the our release on the ControlLogix module, we've done some extensive testing and documentation of those networks and configuration, and it is much quicker, especially being as the fact that we've got some high priority connections. So as we look on our release of the upcoming ControlLogix module, we'll have even more information to provide you for that and the performance that you can expect. But really, 4 millisecond I/O connections is what allows us to say that you can get 4 to 8 millisecond Goose publisher messages out to a device. So another question came through: local mounting with CPU and remote mounting and I/O rack supported. It is supported. There's the recommendation to use EN4 TRs because it supports double data rate on the back plane. And so we'll have some documentation on some architectures for both local and remote mounting, as well as some considerations with the on the ControlLogix side. And then, so the next question, so without Goose Publisher, you cannot send control command to the relay. That is, yeah, without Goose Publisher, you can send MMS control messages to the relay. They're just not, some of the MMS control messages are much slower than the Goose Publisher messages. And so if you're designing some load shedding applications and stuff like that, MMS control messages may not be fast enough for that, but Goose Publisher certainly is. So do the 2 RJ45 jacks on the new module allow for building a ring network, not just parallel redundant to the downstream IEDs? That is, the PRP is the redundancy that most of the protective relays support. With 61A50, I mean, they recommend having managed switches on the network just to help control some of the traffic. So we didn't just implement the 2-port ring on that on the module itself. It is a true PRP, so it's either going to be on PRP mode or simplex mode. So, gosh, good questions. Whether it will support both end-to-end transparent mode and boundary mode of PTP. That is a question that I will need to get back to on boundary mode or transparent mode. I apologize, I don't know that answer off the top of my head. Are there any plans to introduce a standalone version of the new chassis module? At this time, no. We're working on just releasing this ControlLogix module, but there is a potential that we will eventually update the standalone module in conjunction with some other projects that we're working on. I don't have any time frame on that. Who's the best contact for more information on the new module? Any one of our sales people can go ahead and provide you some additional information, or I can reach out to you regarding that and send you out some more information. As I mentioned, we're still in the process of releasing this module. If IED device not support PRDP, only have one NIC, can use, yes. The question is, if you only have one NIC on the IED, can you still use the new module? And the module has the option for simplex mode or PRP mode. And so, yes, you can absolutely still use this module with devices that don't support it. We've had some issues with the gateway module where it did not like when devices disappeared from the network. This caused the driver to fail and try to recover, and the data from the IEDs was stale. Can you speak to improvement for the in-chassis module? So really, yeah, we have done some enhancements to some of the error handling on the new in-chassis module. Part of that was as we provided new support for the Goose publisher. And then also as part of the KEMA testing, we've had to do some additional enhancements to as networks went offline. So yes, we do have enhancements to this module, new module, to be able to handle better when devices go offline. And last two questions. Thanks for hanging in there, everybody. Is there any way to put the new modules in redundant PLC racks? Yes, the new modules will reside in a redundant architecture, but as you know, Rockwell only supports, this module still looks like an IO module, 225 IO connections, and so it must go in the remote rack. The only thing that can go in the PLC racks is the processor and all that stuff. So it does require L8 processors, which I believe the redundancy version of that is, I think it's either already released or coming out shortly. And so, yeah, we'll have some different architectures for how to handle that in redundancy. The other thing is we like having the EN4Ts there, and that's not currently available in the current version of redundancy. So the next question is, will the module support redundancy? Yes, or I'm sorry, it will. At first release, we do not have redundancy built into the 61850 network, but we do have, we will be looking at adding redundancy on the 61850 network. As of right now, it just supports the parallel redundancy protocol. And a couple more questions came in. Currently, the MBI94 MCM Modbus is replaced by a PLX31 EIP MBS4. Any module in MBI series is coming to fit in ControlLogix rack for 61850. Yeah, for 61850, the ControlLogix modules, that new MBI 56E-61850C module. And then there was a question about, will the improvements be rolled over to the existing modules? It will not be rolled over to the existing modules, the PLX82s. Unfortunately, that hardware just doesn't support things like PRP and time synchronization. But as we are releasing newer, more powerful gateway modules, which is something on our roadmap, we will look to see if we can add additional or add 61850 support with some of these new features over in that platform. More to come on that probably sometime next year. So, and then does the new module require L8 processor? It does require an L8 processor. That is correct. The MBI 56E 61850C, because of the large number of IO connections and the fast communication over the backplane, it really needed to be able to have an L8 processor to be able to take advantage of the double data rate over the backplane. So
amazing.
Great questions, everybody. I really appreciate it. I'm sorry we ran over by about 10 minutes, but I appreciate everybody hanging with us. If there are any questions about any of the 61850 solutions or any additional information that you guys need, please feel free to reach out to either your salesperson or myself, and be more than happy to get that information to you.
Yep, very good. And this will be recorded and sent to you as well, so you'll get that in your email. All right, thanks again, Eric. Very good job, and thank you so much, everybody, for joining. And hope you have a good rest of your day.
Thanks, everybody.